Okay, let's see what else major about the software itself before we actually get into building up a schematic later. Um, in setup, you're going to want to play around with your design rules page at some point or another in this default design rules page. And if you can go to clearance here, and this is where you're going to set important things that the board manufacturers are specifically going to care about, which are going to be things like your minimum trace width, maximum trace width. You can change, how close or how big vias are when they're on the same net. You can change all kinds of stuff. You can click each of these, by the way, and it will change all the values across. So if I click this one and I change this to 7, it's going to go all the way across like that. Makes it really quick to change those things, but you're going to want to pay attention to these values when you're getting ready to fab. Otherwise, the board manufacturer is going to yell at you. And doing it at the end is okay if you forget, but chances are you're going to want to start with this. That way you don't have to go modify all kinds of your board layout to, get it to work properly. You can also later choose priorities for how different nets or pins or all kinds of stuff, how things are routed so that they're prioritized, but that's not going to be till later. The other important one is right here. Make sure that if you want this to be in a unit, a specific set of units, you choose it at the start of your project, because trying to make sure that it's set for every window for every part that you make after you started when it's not in the right set of units is going to be a nightmare. I tend to use metric. Metric and mils are the common ones. Mils are 1/1000th of an inch for people who don't know, and metric is obviously metric. And so I'm gonna set it to that by default. And in this case, we're only using a 2-layer board, but if we weren't, you could add extra layers here, and they have to have a bunch already there. But yeah, electrical layers count 2 of 20. 2 is the default. You can modify them and set thicknesses, set the max number of layers, all that kind of stuff. But generally, never have to touch this. And don't touch it unless you want to break things, unless you know what you're doing. In tools, you're going to have a bunch of selections here you're going to use often. One is the parts editor, which we'll get into in the next video. And then you'll have an update from library button so that if you modify a part, you can use the update to actually add the changes from the library into your schematic, because it doesn't by default, in case you want to check, make sure it works before you do. And you have a compare feature, which will actually let you compare this schematic versus your board itself, because like I said, they're different pieces of software, and this is the tool you'll use to make sure they're both on the same page, essentially. And then you've got the ability to do macros and all kinds of other stuff, which I haven't actually bothered to use yet because I haven't needed them. But that is really it for Pads Logic. So let's switch to Pads Layout. Okay. So as you can see, it looks pretty similar to Pads Logic in its layout. There it goes. This is being a little bit slow to load, visually at least. And I'm just going to jump right in and start a new design and give you an overview. Yeah, system startup file. This is what that looks like. There's way fewer toolbar options up here, but each of these will drop down a new toolbar for you to have for whatever it may be. Have a listing of your layers and components, just like in the schematic one. But this is the real deal. This is the actual piece of software you're going to use to make your physical board, or make what will become your physical board. And it's laid out very much the same. Here you actually have access to all the different layers that you're going to have in the board, all your silkscreen layers, and solder mask layers, and top and bottom layers. Those are the important ones. And you have the ability to change how pad stacks in the board actually look and are shaped and such like that. You have you have the ability to change how jumpers work. Here's the example of like a pad stack that actually has options that you can change. And really, there's a lot in this program. And then there's things that are only accessible from this weird modeless command window. Let's see, here we go. So they have this special command window that shows up in all of the subsections of the software that let you do interesting commands, and often very necessary commands that you can't find in a toolbar and you can't find in the right-click menu. That basically just takes you pouring through their difficult to navigate documentation until you find it. I'm going to try and show you any of the ones that I feel are worth knowing about off the bat, and then you can feel free to talk to me in class or actually email me, message me, comment on the YouTube video, however you'd like, and I'll try and help you find something else if you can't find it. Let's see. But you're going to have a bunch of options in these menus. This is the drafting toolbar. This is what lets you put down things like your board outline, which will be in here, copper pores, copper cutouts. There's your board outline, which is going to be important because that's actually what defines the limits of your board. Keep out so that floods don't enter areas. Text, the actual flood tool. Planes, hatches for thermal dissipation, labels, all that kind of stuff. Then you've got your design toolbar, which allows you to do moves and radial moves and basically get things to line up nicely on your board. That can't be done simply by dragging it and dropping it by hand, or at least wouldn't look nice if you did so. And then you have the route tool, because you can actually start routing all of your connections from component to component in this software. I tend to use this one and PADS router interchangeably. I'll jump back and forth between them. I'll do a couple of routes by hand manually to get them the exact way I want. And then I'll move it to PADS router and have the auto router chew through the rest of them, because I don't necessarily feel like routing oftentimes hundreds of connections by hand, when the auto router is designed to do just that. And you have the ability to add jumpers to boards and add test points, all that kind of stuff. You got dimensioning toolbars, so you can get things lined up, or at least measure how far things are away from each other and create arcs and all that kind of stuff. This eco toolbar we actually don't care about at the moment. And I don't expect any of us to be doing ball grid arrays, but if you have a component that uses a ball grid array, there is a wizard for it, so you don't have to do it by hand. Then you're going to have a board zoom button so that it'll zoom to the extent if you somehow get lost or whatever it may be. And then the redraw button, which is very strange, and I'll show you what it does later. That's about it. There's lots of other options, especially in the tools menu. The biggest one is going to be the PCB decal editor. That's how you make the PCB footprint for custom parts. And then some interesting tools like disperse components you'll use, and I'll show you how to use that later. You have pour management, so that you can tell it how exactly you want it to pour planes on, if you have one on your board. And another update from library options, so you can update any of your PCB footprints to your actual model. And then this compare eco tool, which again will sync any changes here with the other two programs. Okay, so let's drop to router real quick and show you that, and that will be the end of this video. Next video will actually make a super simple circuit. Get that, get the accent. And we'll, in this case, you can't actually make a new design in the router because it's assuming you already have a board made in order to do so. So I'll just open one that I already have so you can take a look at it. There you go. So this is something like what an actual board will look like when you're routing it and messing with it in Paths, Router, and Layout. And it looks, again, really similar to the other one. The only difference is you have some new tools. You've got selection filters, a suspend tool, placement, routing. The routing tool is going to be your friend in this particular one because, well, it's Paths Router. You can edit routes, which will also be very useful. But in this case, the routing tool is going to have everything for doing your auto routing and fan outs and optimization. The two most common ones you'll probably use are going to be the auto route and then the optimize, because the combination of the two will end your board with looking very nice. Well, we'll end up with you having a board that looks really nice and is as optimized as possible as far as trace lengths go and how many vias it uses and all that kind of stuff. And you can use these tune options if you're doing high-speed routing, but I doubt that any of us will be, at least in the near future, so it should be fine. And then a center option for getting things lined up nice if you just want it to be a little bit cleaner. And then you've got the interactive route tool, which is actually really cool. You can click on a component lead and interactively route it and make it go where you want to without having to do it completely by hand. It'll take care of most of it. And you just say, I want it to go here in this general area over here, and then it'll just do it for you. It's kind of nice. And then a quick route just does it however it thinks is best. You can move things, stretch it, add corners and splits and smoothing it, and you can protect routes if you don't want them to be changed by the auto router, unprotected if you want it to do it again, and mess with test points, or unroute something if you don't like how it routed it. And I'll just zoom in here so you can see kind of what it looks like. Pretty neat software. And I think that's going to about do it for this initial video. See you in the next one. We're going to design a very simple, basically a flashlight. We're going to have a battery input. It's going to go through a voltage regulator, have a little push button switch to turn on an LED with a couple of resistors, and that's going to be it. But it'll be a good way to start, and you'll get to make some custom parts. So see you there.